Hi and welcome back. Today's episode is about Kmeans. Kmeans is a clustering algorithm used for data discovering. Let's see next how Kmeans works. What are Kmeans characteristics? Let's use Python for discovering Kmeans. Let's go. Okay, what is Kmeans? Kmeans is an algorithm for unsupervised learning. How? We're going to try to identify clusters of data in certain datasets. First, we're going to use a makeblobs function from the library scikit-learn, as I show you here. The idea is to create certain clouds of points where we can manipulate the number of samples, 200 in this case, number of features, it's going to work as columns, the centers, and different other parameters we can use, for example, standard deviation. And random state is for the seed, right? Remember, we can recreate this data by using the number 50. Okay, here I have 200 points, but I could create more points with two or by dimensional data. I can even change this to centers. What means center? Center is going to be the number of clusters. For instance, I have stored this information in data, and when I plot it, I can see 4 different colors. How can I differentiate the colors? Okay, when we create makeblobs, the data will contain 2 different things. First is going to be the information regarding the dimensions, x and y in this case, because I have 2 dimensions, and the other one is going to be about the label. In data 0, we will have this numerical information for plotting the point. In the second one, in data 1, we will have the information regarding to the label. Okay, what would you need? We need scikit-learn, NumPy, matplotlib for data visualization, Pandas for data manipulation, and then we're gonna start. Let's see. As you can see, I have 4 different clusters here, but of course the algorithm will not know this. The following now, we're going to talk about how Kmeans works. How Kmeans work? Well, first of all, we have to give a parameter to Kmeans. Which parameter? The number of clusters. Kmeans is an algorithm that needs the number of clusters we believe the data has, or we have certain idea about this number of clusters that we can change, of course. What else? Well, given these 4 clusters, Kmeans will randomly set 4 different points in a bidimensional in our case that we're gonna call centroids. These centroids will change in different steps, and at the end, Kmeans will find the optimal position for each centroid, as I mentioned here. And those centroids will be the center for each cluster. We will see in next videos how to calculate the distance between each centroid to each point of each cluster, and how Kmeans try to reduce these values. Okay, let's go. Kmeans. Here I want to show you points. I store them points, all the data about that data, the points. Okay, here you have to call using the library scikit-learn cluster, then import Kmeans. Here we're gonna create an object called Kmeans. Well, you can call it as you want to, right? My Kmeans, and so on. The difference between this one is K and M capital letters. Meanwhile, in this one is minuscule. Okay, small letter K and M. Here we're going to give the number of clusters we believe our data has. Okay. That's one of the advantage and disadvantage at the same time of Kmeans. If you're discovering data, you don't know how many clusters are. But if you have certain idea about the data you are using, you can say, okay, I want Kmeans to divide it or partitionate my data in this number of clusters. As I said, is an advantage and a disadvantage at the same time. And as I mentioned too, Kmeans will partitionate my data. That's why Kmeans is called a unsupervised algorithm and partition algorithm at the same time. Okay, because that's the way it works. And I'm going to feed my data now. Here I just create the object Kmeans. However, now we're going to call Kmeans. Now my Kmeans has a function called feed where we will pass the data. Keep an eye on this and attention. Point is only the information for plotting the data, right? 2 dimensions in our case. Here you can see, okay, an object with 4 clusters, and it's done. It's done. Kmeans was fit, and now we can see where are those centroids or the centers using cluster centers. That was fast, right? That's one of the advantages of Kmeans. Practical and simple and quick, right? As mentioned here, Kmeans is used for clustering due to its speed and simplicity. As you can see, I can have here all the information regarding my centers. This is for X and this is Y for the first cluster, the second cluster, -2 and +10, and so on. Now we can see using my object Kmeans, and I call the function label, who are those groups. The first point will belong to the second group. I said second, remember that Python, the first group is 0, the index 0. So this one is the second group, the fourth group, and so on. Now we will check if Kmeans cluster my original data, my blobs, as we supposed, or it's supposed to be. This information here is just for new, if you want to create new clusters. That's just I want to mention this, but it's not so important now. But if you want, or you have new information, you wanted to cluster it with your original data, just called predict. Predict will help you if you have new points and you already fit your clusters using Kmeans, and then Kmeans will predict or will cluster those new points. Okay, let's see how Kmeans did it. Okay, here I'm going to give different colors to each group. For example, here I'm saying, okay, you're going to plot all the information, but if new points, that are the original points, of course, if they were labeled as 0. As you can see here, if my points in YKM were labeled as 0, you're gonna color it on red. Check this. This one is for the second axis, then this one is for the first axis. Of course, this is X, and this is gonna be Y. And the information regarding all those points labeled as 0. And so on for the other one, of course. As you can see, this one is all those points that were clusters group 1, black. So all in one simple figure. You can see here, okay, these were cataloged or labeled as 0, the group 0, the group 1, the group 2, and the group 3. It looks like Kmeans did its job, right? Let's see, and now I can do it in a simplest way, in a simpler way. You can see here, point is my data, and I have the first dimension, and this is the second dimension, and just call Kmeans. Kmeans was the first Kmeans object I fit, and this CMap rainbow is for giving certain scale of colors. You can see this is much simpler than the other one, and let's see. Okay, as we can see, Kmeans was capable of partitioning my data in 4 different clusters, and it's supposed to do it. That's a great advantage for when we're using Kmeans. It was simple, and it was quick, or it was fast, right? And it was possible, or it is possible, to partition my space. How? With the number of clusters I provide. In the following videos, we're going to talk about how to change Kmeans for selecting the best number of clusters. When I say changing number of clusters, we're going to change this number of clusters. People call it K. So we're going to manipulate K, choosing the best number of clusters. Because here it was simple, right? This example was simple because we knew that they were 4 clusters. However, we could change it. You can see here, I'm going to show you now, and I'm going to feed the data, and we will see how it changes. I come directly here. As you can see here, Kmeans change one group. Which group? This one over here. Now it's divided in 2 different clusters. The other ones remain the same. However, these blobs or cloud of points we saw at the beginning now was partitioned too. Why? Because Kmeans forced the data to be partitioned in 5 parts. Okay, that's how Kmeans works. In next videos, we will talk about how to choose the right number of clusters, as well as how to normalize the data. Hope you like it, and see you next time.